Hello, I'm ETarte, math teacher. This is a solution video for my math challenge, Perpendicular Bisectors. In that challenge, I present a triangle in the coordinate plane with its bottom side along the x-axis going from 0, 0 out to 2a, 0, and its top vertex having coordinates 2b, 2c. And I'm showing here in red the perpendicular bisector of each side of the triangle. Each of them makes right angles with that side, and each of them splits that side into two equal sections. And the challenge is show in this setup that the three perpendicular bisectors all meet at the same point. Well, here's my solution. The first thing I do is to get the coordinates of those three midpoints, the 3 points where the perpendicular bisectors intersect the sides of the triangle. And to do that, I use the midpoint formula, which I presented in the challenge video. To use that formula, you take the coordinates of the two ends of the segment, add them and divide by 2. You do that to the x's and to the y's to get the x and y of the midpoint. In other words, you're averaging the x's of the ends and averaging the y's of the ends. Doing that, we find that the coordinates of this midpoint are b, c, of this one a, 0, and of this one a plus b, c. Next, I need to get the slopes of the three sides of the triangle, particularly of the two slanted sides, the sides going up to that top vertex. The slope of the bottom, since it's horizontal, is 0. To get the slopes, I use the slope formula, which I gave in that original video. It's the difference of the y's over the difference of the x's. For this one, it's 2c over 2b, which simplifies, reduces to c over b. And for this one, it's 2c over 2b minus 2a, and that simplifies to c over b minus a. Now my next goal is to find an equation of each perpendicular bisector. With this one, it's vertical. Every x coordinate on this perpendicular bisector is a, and so its equation is the typical equation of a vertical line, x equals a. Now, in order to get an equation of each of the other perpendicular bisectors, this one and this one, we're going to have to get the slope of each of them, and to do that we have to understand the relationship between the slope of a line and the slope of any line perpendicular to it. Here's an example. I have here two perpendicular lines shown in red. This one goes up to the right, so its slope is positive. The other one goes down to the right necessarily, and so its slope is negative. Slope is rise over run, so the slope of this one is 3 over 2. The slope of this one is negative 2 over 3. And that's an example of how the slopes of two perpendicular lines compare. One of them is positive, the other is negative, and the fractions are flipped. So, since this slope on the left is c over b, the slope of the perpendicular bisector is going to be negative b over c. And since this slope on the right is c over b minus a, I flip the fraction and change its sign. To change its sign, I simply change the signs of the denominator from b minus a to a minus b. And I have the new slope, the slope of the perpendicular bisector, a minus b over c. So now I can write an equation of each of those perpendicular bisectors using the point-slope form, which I referred to in the original video. For this one, the one on the left, we have y minus c, which is the y coordinate we know about, equals the slope, negative b over c, times x minus the x coordinate that we know about, that's x minus b. So we have y minus c equals negative b over c times x minus b. Now the other one, again using point slope form, turns out to be y minus c equals a minus b over c times x minus a plus b. Now each of these is going to intersect that vertical perpendicular bisector somewhere, and we want to show whether they both intersect it at the same point. Well, since they both will intersect this vertical perpendicular bisector, and its equation is x equals a, I will replace x by a in each of these equations. So here are the new equations with x having been replaced by a in each of them. So looking at the equation on the left, I distribute the negative b over c to the a minus b, and I get y minus c equals negative ab plus b squared all over c. The equation on the right takes a little more work, so we have y minus c equals a minus b over c times, and I distribute the negative inside these parentheses, times a minus b. The a minus a adds up to 0, so I have y minus c equals a minus b over c times negative b. I distribute the negative b here, and I get y minus c equals negative ab plus b squared over c. Well, I've got the same thing on both sides. With both equations, I now add c to both sides, and I get y equals the same expression for both lines. Y equals negative ab plus b squared all over c plus c. So that is the y coordinate where the 2 points meet on that vertical perpendicular bisector. That is, the coordinates of the point where they meet are the x coordinate is a, and the y coordinate is this expression which we have on both sides. So all three meet at that point. So that's my solution to my perpendicular bisectors math challenge. Thank you for watching and listening.